and we can find the output by input. So block diagram reduction algebra we are going to use for that, right? So we have some 11 rules in this using which we can reduce the given big block diagram. We'll solve some problems after this class using this rules, 11 rules we have, how we are going to reduce the given block diagram and find the transfer function, right? So rule 1 we have here, which is two blocks G1 and G2, gain blocks we can call connected in series, which is cascaded in series. A is the input, Y is the output. So Y here is equal to A into G1 into G2. So when two blocks are connected in cascaded, they are connected in series also we can say. So we are going to multiply the blocks gains G1 and G2. So that is the rule 1. Then we have the rule 2, in which we are going to take another G1 and another G2, and these two are combined using this called as summing point. This cross mark with the circle is called as a summing point, where we are combining parallel blocks G1 and G2. Okay, so this is also called as combination of combining a feed forward path. Why it is called as forward path? Because from input to output we are taking this connection, this one we are taking input to output, so it is feed forward only. If we take output to input like this, which we will have in the later rules, then it is called as feedback, output to input. This is input to output, that's why it is called as feed forward path. So in such a case, if you have here plus, here we have plus, here also we have plus, then Y is equal to A into, we are going to add G1 and G2, right? Suppose here if you have minus, so we are going to take it as minus G1 plus G2. Suppose here we have minus in this case, so then we take it as minus G1 minus G2. So like this we are going to add the two blocks which are in parallel forward path. So we have another rule, that is rule 3, where we are going to take, for example, a block G is there, input A we have, output Y we have, and we have this point which is called as branch point or takeoff point. Suppose we are taking the signal from here, we are going to get it as suppose X, which is nothing but A only. We are taking from here, so we are taking from here, so it is called as takeoff point, or sometimes it is called as a branch point. So the here we want to shift this branch point ahead of the block G. We want to shift this ahead of the block G. So what will be the change we have to make? That will be the rule. Why we need to shift this branch point or takeoff point is because when we want to reduce the block diagram into a single block, we need to do some adjustments. So during that we require to do this adjustment of moving the takeoff point, or it is also called as branch point, moving the branch point ahead of the block G. We will see when we see the problem, when we are going to solve, we will understand more clearly what is the need of moving this branch point ahead of the block. Suppose if we move this, the break branch point, instead of taking the signal from this point, we are taking the signal from here. So what we get is A is the input, Y is the output, but this signal here we have is nothing but A into G. So now x is going to become a into g, whereas it has to be just a. We know already, we have seen that when we taking the signal from input like this, we are getting some signal x which is nothing but input a. Now we want to shift the takeoff point without disturbing the signal x value. We want to just make some adjustment to reduce the big block diagram, which we are going to solve the problems into single block to find the relation between output and input, which is called as the transfer function. So when we move the takeoff point or branch point ahead of the block, we should get the same a, but here we are getting a into g. So what we do is, we will be adding extra block here, which is nothing but, which consists of 1 by g. The block we are going to add, we are introducing a new block. So what happened now? At this point we have a into g, right? That is now multiplied, a into g is multiplied with 1 by g. So this g and g get cancelled, and finally we get it as a only, which is nothing but x equal to a we get. So that is the correct, right? X equal to a we want. Even we shift the takeoff point ahead of the block, the signal value should not change. We are making the adjustments, moving the takeoff point or branch point. If we don't take this 1 by g block here, and if we just take directly the signal from this point, so then what happens? We get x equal to a into g. I am again explaining this, you can listen because it's a little typical. Suppose if you take directly here, x is going to be a into g, whereas our x is just signal a. We want to shift the takeoff point, but without disturbing the signal value of x. But what is happening instead of this? Before the block we have the takeoff point. If you are moving the takeoff point ahead of the block, and from there if you are taking the signal, it is going to be a into g, but we want only a. So to make that it as a, we are introducing a new block here whose gain is going to be 1 by g. So now what happens? The signal which here we are getting, which I am making the darkening, into g into 1 by g. So finally x is equal to a into g, which is into, we have introduced a new block called 1 by g. So g will get cancelled and x equal to a. So finally what we are getting the signal? X equal to a, which is we want. Even after shifting the takeoff point also, the signal level should not be disturbed. Okay, that's why we are introduced 1 by g here, right? That is rule number 3. Next we go for rule number 4, where we are going to take this g here we have, and a is the input, y is the output, and suppose we have take x signal, and we are taking from this point, and now the signal level strength is nothing but a into g. Now suppose we want to shift this takeoff point or branch point from after the block to before the block. We want to shift the takeoff point from after the block to before the block, so that we make some adjustment and reduce the big block, which we'll see in next problem. Now you just remember what are the changes we have to make when we shift the takeoff point ahead of the block or before the block, what we get. Okay, now if you just shift the takeoff point from after the block to before the block, that is like this, x signal what we are getting here is a, but actual signal is a into g. So what we have to do is we are going to introduce a new block with the gain of G, right? So now what happens, it becomes as A into G, right? So what here you have to remember is moving the branch point or takeoff point before the block, then we have to introduce a new block G. If you are moving the branch point or takeoff point ahead of the block, then we have to introduce a new block called as 1 by G, which is rule 3, right? So next we have another rule number 5. So rule number 5, now we have a new term called as moving the summing point. Up to now we have seen what is takeoff point. Now we'll see the summing point, moving the summing point ahead of the block. So we'll see what it is now, ahead of the block G, right? So summing point already we have seen in the rule 2. This is the summing point to which we are given A input, and here we are given B input. 2 are added, here you take it as plus, here also you take it as plus. So here what we get is A plus B, adding of this, and in between we have a gain block G. So here what we get is A plus B into G. So this is the actual one. Suppose we want to move the summing point ahead of the block, that is we want to move this summing point from this point to ahead of the block G to make some adjustments. Why? We will understand when we solve the problems in the next class. So when we move this summing point ahead from this point to the ahead of the G, so what are the adjustments we have to make? We'll see now. That is the rule number 5. Okay. Suppose we have here G, right, which, and now we moved the summing point, right? So now for this input G, it is A only. Here we getting A into G. Suppose if you directly add B input to this and take the output Y, right? Here what we have B, no block is there in between. We have B. So if we take directly this block B signal and connect it to the summing point without making any changes in the path of B, so what we are going to get Y is AG plus B. We have moved the summing point ahead of the block. We made the adjustment for simplifying the given block, big block. We'll see that. Again I'm repeating the same thing, AG plus B. But actually what we have to get is A plus B into G we have to get. Even if we move the summing point, also the signal has to be A plus B into G only, as we have seen in the takeoff point case here also. But we are getting AG plus B, so the B is missing the gain. So what we have to introduce a new block with the gain G. We are introducing. Now what happened here, we get is as BG. So instead of this, now what we get, Y is equal to AG plus BG, which is nothing but if you take out G common from this, so we get A plus B. So this is nothing but, so what you have to remember here is when we move the summing point ahead of the block, we are going to introduce a new block G, which is there in the blue color here. So that is the rule number 5. Okay. Next we have rule number 6, moving the summing point before the block. Earlier one is ahead of the block, now moving the summing point before the block. It is right. So what we have, we take this is G, the gain g we have, and the summing point here we have, this is plus, and output here input a, here we have ag, here we have b signal. So here what we get is ag plus b will be the output. Now we want to move the summing point before the block. We want to move the summing point before the block. Okay, we need to do the adjustment. So we want to move the summing point before the block. Suppose if you move the summing point before the block and don't add any extra blocks, then what happens? That we'll see now. So we've just moved the summing point before the block and we add b, and here we have a. So the signal here we get is a plus b, and the y signal is going to be a plus b into g, we get a plus b into g. But whereas the signal, actual signal before we made the adjustment is ag plus b, but here what we are getting is a plus b into g, which is nothing but ag plus bg. So we got an extra signal for b which we don't want. Even we move the summing point before the block, the signal should be ag plus b only, ag plus b only, it should not change. So what we have to do, so we will be introducing a new block with the gain 1 by g. If you introduce a block 1 by g, then what happens here when we change it? So here we get, after the summing point, we get a plus b by g. Now when this is a plus b by g is passed through this block g, so we get g into a plus b by g. So if you multiply this, so what we get, ag plus b by g into g, g will get cancelled and we get ag plus b, which is the actual signal which we want. So what we have to do here is, whenever we are moving the summing point before the block, we have to introduce a new block 1 by g in series with b signal. Then we get the signal a plus ag plus b. Right, this is rule number 6. Then we have rule number 7, which is interchanging the summing point. That will not have any effect, no need of introducing new blocks when we do the just interchanging the summing point. If you have two summing points and we want to interchange the summing point, to make the adjustment, there will be no new block will be introduced. So here suppose we have b and here we have a, here a plus b, and here we have another summing point plus b. These are summing point, just adding the signals. Here we have minus. So overall we get, from this point we get a plus b, from this path we get minus c. So overall signal we are getting here is a plus b minus c. Suppose we interchange this summing point, that is, suppose you take it as 1 and 2, and 2 position we take 1 and 1 position we take 2, just interchanging the summing point, no need of introducing any new block. So that is, here if you add c signal, and here we have taken the summing point plus, and here we taken the b. So here we get, at this point we get a minus c, and at this point we get a minus c plus b. So we get it as nothing but a plus b minus c, which is same as this a plus b minus c. So no need of any introducing of new blocks when we just interchanging the summing point. Very simple it is. Next we will see rule 8, where we are going to split the summing point. Whenever we have more than two inputs to the summing point, we can split it, the summing point, splitting into two summing points. For example, we have the summing point which have A input, which have B input, plus plus, and here we have another C input. So overall the output here we are going to have A plus B plus C, and we are going to split this single summing point into two summing points like this. This is one, this is one. So to this we give A input, to this we give B input. So here we get A plus B, and another input here we get it as C. So here we get A plus B plus C. So no need of any introducing of new block when we split the summing points, right? Same way it is, we have another rule. These are the simple rules. Combining the summing points. This is combining. Suppose if you have two summing points, combining the summing points. Two summing points if you have, okay, this is one. Here we have A, here we have B, and here we have a summing point, here plus. Suppose you take it as minus, so here we are going to get A plus B minus C. Two summing points here we have. We can combine these two summing points into a single one, and we can give all the three inputs here. It is B, it is A, and here we have input, we give it as C. So here we get A plus B plus minus C. A plus B plus minus C, both are same. So splitting the summing point is one rule, combining the summing point is one rule, right? Now little very important rule we have, that is rule 10, where we are going to eliminate the feedback loop. That is very important. Now we come, basically this is a summing point. Here we have input R. Suppose we take G is the gain path in the forward path, input to output we have, and suppose we are taking from the output, this is output, from the output, and we are giving at the input with the negative, it is feedback, and the feedback transform H we have. So here is the output. So now what our aim is, eliminating this feedback loop, and since here we are giving the negative, so here it is eliminating negative feedback loop, eliminating negative feedback loop here. That is the rule we have, eliminating the negative feedback. Why we calling it as feedback? Because we are taking the signal from output towards the input, from output towards the input we are moving, so that's why it is called as feedback path. So when we want to eliminate this feedback path, suppose take it as C as the output signal, and here we get C into H, and now here R, this signal I am writing R, since here we have minus, R minus CH we have, R minus, since here minus is just a summing point where we are adding this R minus CH, so here we have R minus CH, and at this point what we get is G into R minus CH, because R minus CH is passing through this G, into it will be multiplied, it is in passing through, so gain we get, so G into R minus CH, which is nothing but C, right? So C is equal to what we can write, C is equal to G into R minus CH, G into R minus CH. Now if you simplify this, GR minus G into C into H. Now bring this minus GCH on the left hand side, so we get C plus GCH is equal to GR, and now we take C common here, so we get 1 plus GH is equal to G into R. R is the input, G is the gain path. Now bring this R on the left hand side, so we get C by R, and bring this 1 plus GH on the right hand side, in the denominator we get G by 1 plus GH. 1 plus GH. So this is very important formula which we use, and this is called as the transfer function of the given block. Transfer function. This is output C and divided by the input signal R gives G divided by 1 plus G into H. This, if you take in terms of S domain, we can even write G of S by 1 plus G of S into H of S. So what here we have done is, finally we eliminated the block and we got here G by 1 plus GH. Output we got is C, input we got as R, and C by R finally we got it as G by 1 plus GH. So this is eliminating the negative feedback loop. I have told you why it is called as feedback, because we are taking the output and we are giving it the input. Same way rule 11 is eliminating the feedback only, elimination of positive feedback loop, elimination of positive feedback loop. The difference is, here we have the summing point, here we have the input, plus here we have G's in the forward path, here we have the output C, and we are taking the feedback from output towards the input, and with the H as the function we have taken the, and why it is called as positive feedback, here we have positive, and whereas in the rule 10 here we have it as negative. So this is negative feedback, which is related to amplifiers which are stable system, and when it comes to the positive feedback, this is related to oscillators. Positive feedback, unstable system where we get the oscillations. Now suppose you take here, this is C, and here we are going to C into H, right, and this is a summing point which where we add R plus CH, and when this is passed to the G block, as usual we get G into R plus CH, so which is nothing but equal to C. So G into R plus CH is equal to C. Now if you simplify this as we have done in rule 10, GCH is equal to C. We bring this GCH on the right hand side, GR is equal to C minus GCH, and if you take out C common, 1 minus GH, this is little simple only, G into R. Now if you bring this 1 minus GH on the left hand side, R on the right hand side denominator, so finally we get here it as G by 1 minus GH, which is equal to C by R. So what here we have to remember is, when we take the positive feedback in the denominator, we are going to have negative. When we take the negative feedback in the denominator, we are going to have the positive. So these are the 11 rules which are going to be used in simplifying the big block diagram into a single block and find the transfer function of the given system. Thank you very much. We'll meet again in the next class. Thank you. Please subscribe and share. Thank you.